let's talk about the unit circle as a way to remember values of trig functions. So we've seen trig functions in terms of a triangle. We'll have like a triangle here, maybe an angle, let's call it theta here, and let's just call this side x and this side y, and let's just say the hypotenuse is 1. Then for this triangle we have sine theta equals opposite over hypotenuse, so just y, cos theta equals adjacent over hypotenuse, so just x, and tangent theta equals opposite over adjacent, so y over x. So what the unit circle is it puts this triangle inside of a circle with the radius 1. And then if you've got a point x, y on the circle, well, that becomes cos theta sine theta. So now you can think about cases where, like, what if theta is all the way, instead of being around to here, what if it's all the way around to, like, here? Well, this point on the circle, theta is 180 plus, so midway between 180 and 270 would be 225 degrees. This point here would be root 2 over 2, root 2 over 2. And then you can tell right off the bat, okay, well, cos 225 degrees equals root 2 over 2, because that's the x, and then the y, sine 225 degrees equals root 2 over 2, and then the tangent, tan 225 degrees equals root 2 over 2, divided by root 2 over 2, which just comes out to 1. So the unit circle reduces remembering these trig values down to remembering points on the unit circle paired with angles. So let's talk about how to remember the points on the unit circle. So let's get rid of that. Doesn't want to get rid of that. Oh, we'll just refresh. Alright, so unit circle. So we'll start at the rightmost side, right here. So unit circle has a unit radius, it has 1, radius is 1. So this is pretty easy to see, 1, 0. And we say that's a 0-degree angle if we're just extending up to here. So that's telling us that cos theta is 1, cos 0 is 1, and sine 0 is 0. Now the next one is 30 degrees. At 30 degrees, then our point is root 3 over 2, comma 1/2. So cos of 30 degrees is root 3 over 2, sine of 30 degrees is 1/2. Next up, 45 degrees. Here we've got root 2 over 2, root 2 over 2, and at 60 degrees, we've got 1/2 root 3 over 2. And at that point, we're pretty much done. If we, like, this point right here, 90 degrees, it's kind of like this point, except flipped around. So 0, 1. Then if we want to mirror on this side, 60 to 90, the 90 to 120, then we just flip this thing around, and make it -2 because the x coordinate becomes the y. So negative 1/2 root 3 over 2. Oh, I didn't mean flipped around. I mean just flip the sign of the x. That's what I meant. Then this 45 degree thing then goes to negative root 2 over 2, root 2 over 2. We keep continuing on. Negative root 3 over 2, 1/2. And then you keep going, negative 1, 0, negative root 3 over 2, 1/2, and it just repeats on and on and on. So, say you wanted to find sine of, let's say sine of 330 degrees. Well, you could look at the unit circle and say, like, well, this is like 30 degrees before 360 degrees. The whole thing is 360 degrees. So 30 degrees beforehand is going to be right here. And remember our options, it's always over 2, so it's something over 2, something over 2. And on the top, it's either 1 root 2 or root 3. Root 2 is when they're equal to each other, but at 30 degrees, the x part is going to be bigger. So the x part is going to take the root 3, and the y is going to take the 1, and then lastly, y here is negative. So sine 330 degrees equals negative 1/2. We also know cos 330 degrees equals root 3 over 2. And if we wanted to find tangent of 330 degrees, well, we just take y divided by x. So negative 1/2 over root 3 over 2. Since they're both over 2, these can cancel out. So it's just negative 1 over root 3. 1 over root 3. And you usually see that as negative root 3 over 3. So that's how you can find values of angles that are that you can find by reflecting or rotating these kind of angles in the unit circle. Now, other angles, like what if you wanted to find, well, what if you wanted to find like 50 degrees or something like that? Well, you can't really do it with the unit circle this way. You need more advanced methods, and we'll get into some more advanced methods later. But for now, this is a pretty good start to finding the value of the trig function at any nice kind of angle.